we're going to create a quadratic function from the actual graph of the parabola. And to do that, we need 3 points from the parabola. So here's the parabola, and we're going to come up with the equation or the function, and we do need 3 points. And you want to be very exact, because if you're not exact, you won't get the exact function. So we're going to start here, and we're going to identify 3. There's one right here we can use. That would be at 2, 9. We look through, find another one. We have one down here at 0, -5 we can use. And then we can also use a -2, -3. Now any points would work, but these are the ones that I've chosen. You know, you could use this one also, but like I said, make sure that it's obviously a point. You know, don't use this one and guess that it's at -2.5, because it might be or it might not be. So we're going to use these 3 points and come up with the function, and we're still going to use our generic quadratic here of ax squared plus bx plus c. And what we're really looking for here is the values of a, b, and c. And we have, 3 unknowns. So that means we're going to have to come up with 3 equations. Luckily, we have an x and a y value 3 times. And that's why we needed these 3 points. Remember, f of x is our y. And so all we're going to do is just simply plug in these points 3 times. Now, there's a reason why you would love to have your x value 0. Okay? Anything on the y-axis is going to be very simple, and we're going to start with that one. Our f of x is y, so we're going to take -5 equals a times 0 squared plus b times 0 plus c. Okay? And, a times 0 and b times 0 are just 0, so we have -5 equaling c. Okay, so we already have one answer. So if at all possible, you really want to use a y-intercept. Okay, but we're going to keep going, and we're going to jump to use the point 2, 9. So our y value in this case is going to be 9, and that's going to equal a times 2 squared plus b times 2 plus c, but of course we already know that c is -5, so let's just put that in right now. We're going to simplify this down. I'm going to add the 5 over to the 9 and get 14 equals 4a plus 2b. Alright, and we're going to jump over here and use the last point that we haven't used yet. And our y value in this case is -3. And that equals a times -2 squared plus b times -2 minus 5, because that's our c again. Okay, and we're going to go through and simplify these. And I'm going to add the 5 over, so we'll have 2 equaling 4a minus 2b. Just watch your signs, make sure you're doing your order of operations correctly. Now, we have one of our variables solved for, and so we just have 2 left, and we have 2 equations, so we have 2 equations, 2 unknown. And I'm actually going to make this a little simpler in that we can divide all of these by 2 and all of these by 2. So I'm just going to make these 2 equations a little simpler before we move on. So dividing all 3 of these terms by 2 would get us 7 equals 2a plus b. So we're going to use that information. And then we're going to divide every one of these terms by 2 as well. and get 1 equals 2a minus b. Okay, so here are the two equations that we're going to use. So if you remember your methods of solving two equations, two unknowns, you will be able to tell right away that this is a set up perfectly for elimination. We have a positive b and a negative b, so I'm just going to add these straight down, and our b's will cancel, so we'll have 8 equals 4a, divide both sides by 4, and a equals 2. And we still want to solve for b, so we're going to plug that in to, it doesn't matter which one, I'm just going to pick the first one. So we have 7 equals 2 times 2 plus b, so 7 equals 4 plus b, subtract 4, and we'll see that b equals 3. Okay, so if you remember what our c was, which was negative 5, we have the information now. We have our a, our b, and our c, and we're just going to plug that into our generic formula. So f of x equals 2x squared plus 3x minus 5. And this is the quadratic function that would produce the parabola we saw on the previous slide. So here's the parabola we're going to use for our final example here. And you notice that it opens down, and that should tell you that the first value, the a, is going to be negative. But we still have to come up with 3 points. And again, if at all possible, we want to use this one. And I say if at all possible because you're not going to want to use it unless you can tell exactly what value it is, where it exactly crosses the y-axis. In this case we can, so we're going to use that. So the first point is going to be 0, 7. Okay, then we need 2 more points. We can use the vertex here, which is at 2, 11. And we'll use this point down here also, so at negative 1, 2. Alright, so we're going to use our generic quadratic here, and we're going to use our 3 points. And again, I would start with the y-intercept if you have it. It'll save you a few steps. So we're going to just plug in the y value of 7 and the x values of 0. The a and the b are gone, and so you're left with c equaling 7. Now we're just going to move across to use the point negative 1, 2. 2 is our y value, and that equals a times negative 1 squared plus b times negative 1 plus c. We're going to substitute c as 7, so we'll have 2 equals a minus b plus 7. Subtract 7 to the other side, and have negative 5 equaling a minus b. Now, we can't simplify this further like we did on the previous example because there is not a number that goes into all 3 of these terms. So this is the one we're going to use right here. Okay, but we're going to move to 2, 11 and use that one. Again, 11 is our y value. And we're going to say a times 2 squared plus b times 2. And our c value is still 7. So if I simplify this, I'll subtract the 7 over and get 4. 2 squared is 4a plus 2b. And in this case, all 3 terms are divisible by 2. So I'm going to divide them all by 2 and get 2 equals 2a plus b. And we're going to use these 2 equations to finish this off. Okay, so we're pretty lucky again in that this is set up perfectly to eliminate the b's. So I'm just going to add straight down again and get negative 3 equals 3a. We'll divide both sides by 3. A equals negative 1. And I will substitute that back in, and I'll take the second equation here and figure out what b is. So we have 2 equals 2 times negative 1 plus b. So that's 2 equaling negative 2 plus b. Add 2 to both sides and get 4 equals b. And we also remember from before, c equals 7. So the quadratic function that produces the parabola is f of x equals negative 1x squared plus 4x plus 7.